So today we are going to discuss things about circuit theorems. In circuit theorems we have four things to keep in mind. The first is the superposition theorem, followed by the Thevenin's theorem. Then we have Norton's theorem. Finally we have maximum power transfer. Okay. Let's talk about what is linear. Okay, linearity, and which this thing we have covered in our previous sheets. And the important thing to remember here is that power is not linear because its formula itself doesn't follow neither homogeneity nor additivity. Let's talk about superposition theorem. The definition here has been asked many a times in UPSC engineering services prelims exam, so this is something you need to go through. Voltage or current through an element in a linear circuit is the algebraic sum of voltage or current through the element due to each independent source acting alone. Helps to analyze linear circuit with more than one independent source by calculating contribution of each independent source separately, taking one voltage or current source at a time while the rest of the voltage sources are short circuited and current sources are open circuited. Dependent sources are left intact, calculating the value of voltage or current using KVL, KCL, nodal or mesh analysis due to one source. Then we are moving ahead to Thevenin's theorem. And Thevenin's theorem is basically for the circuits which have a variable element and a fixed element, and we are trying to find out an equivalent circuit for the fixed part. Okay, technically we are converting this particular circuit into this one. Okay, to find out a VTH we have open circuit terminals. Okay, we are open circuiting the terminals and then we are calculating the VTH, while for calculating RTH we have independent sources turned off. Okay, we have all the sources turned off and then we find the internal resistance of this particular section of the circuit. Now, an important thing to remember is absence of independent sources leads to VTH equals to 0. If in a particular question it is asked that there are no independent sources and then you calculate so and so and so and so, you directly mark the option 0. Okay, you need not to calculate, they are simply trying to waste your time. Okay, then we have RTH. For RTH we need to disconnect the load and we have to turn off all the independent sources. Then we do turning off independent sources means we are short circuiting the voltage sources and open circuiting the current sources. Now the internal resistance across the terminal is equals to RTH. First we are shutting down all the supplies we have. Okay, and what we are doing is we are calculating the internal resistance of the circuit. Okay, solving questions will make it more easy to understand, but for the time being we are strictly concerned with the concepts. Now we have some cases. First case is when we have independent sources only. This is the easy process to follow. We have independent sources only, and this is what we have discussed so far. But the case 2 arises when there are both dependent and independent sources. Okay, then what we have to do, the first process we are going to perform is the test source. We are applying a voltage of our choice at the terminals. Okay, and then we determine the current I naught. Okay, and we calculate RTH by using this concept. This is basically the Ohm's law. Then when we get the RTH value, then we are using the short circuit current. Okay, we are short circuiting this AB terminal and then we are trying to find out I short circuit, that short circuit current at AB terminal. Now RTH equals to VTH upon ISC. This will lead to we can find out VTH with this process, because earlier we have found out RTH, we have determined ISC. Now it is easy to calculate VTH. Now an important thing to remember is, in case the value of RTH is negative, then the circuit is said to be supplying power. Mostly it doesn't happen that you get the value of RTH as negative, but it may happen. Okay, students get worried a lot that they are receiving a negative value of RTH. It is nothing to worry about. Okay, the negative sign simply means that the circuit itself is delivering power. It is not absorbing it, it is rather delivering it. Okay, so what you have to do is, when you write the main answer, you write the simple value of RTH. Suppose you are getting RTH as minus 7 ohm. You write down RTH equals to 7 ohm, and in bracket you have to write the circuit is delivering power. Okay, so this is all for Thevenin's theorem. Then we are moving ahead to Norton's theorem. It is same as that of Thevenin's theorem, but with slight difference. Here we are converting the circuit into this format. Okay, we are having a current source and a resistance. In Thevenin's theorem, we were having a voltage source with RTH, but here we are having current source with resistance. Okay, this is the format we are going for, and for the same conditions. Okay, here also we are having a moving variable element and a fixed elements. Okay, then we have IN equals to short circuit current at terminal AB. RN is the independent sources are off, means voltage sources are short circuited and current sources are open circuited. Then we have IN equals to I short circuit, SC short circuiting at AB. Okay, sources are not off. In order to find out short circuit current, you do not turn off the sources. Okay, here we are not turning off the sources. Here we used to turn off all the sources. We were short circuiting voltage and open circuiting current sources, but here we are not doing so. Only for finding out RTH we are doing, but R in RTH is in Thevenin and RN is in Norton. An important thing to keep in mind is dependent and independent sources are treated same in this Norton theorem. Okay, we are not treating them differently. Here what we used to do in Thevenin's, we had separate process for both dependent and independent sources. We have with the independent sources only. Okay, this was the process, and when we had both dependent and independent sources, we had this process. But in Norton's, it is not so. We are treating both of them equally. Now, an important thing to remember here as well is, in case of dependent sources only, in the circuit, if you have dependent sources only, then IN equals to 0. Okay, don't get stressed because in case they are mentioning in the question that dependent sources are not available, and still you are busy solving the question over and over and wasting your time. The simple thing to keep in mind is this statement, and don't fall into the traps of UPSC engineering service exam. They are purposefully trying to waste your time and lose your confidence also, so people get nervous over there. Then we have to find out RN, we have voltage as short circuit, current as open circuit, and so on and so forth. Now Thevenin and Norton are related by source transformation. Okay, this particular circuit is same as this particular circuit, as we have studied previously the source transformation, and this is following the same thing. Hence source transformation is also called Thevenin-Norton transformation. Now, an important thing to remember here as well is, if RTH is infinite, then Thevenin is not possible, Norton is possible. Okay, but if RTH value is 0, then Thevenin is possible and Norton is not possible. This thing will help you out in many GATE exams and as well as ESC prelims exams, but I will not guarantee you in mains exam of IES and IAS. Okay, so keep in mind, this is the fundamental thing of 1 marks or 2 marks, so it will be suitable for ESC prelims and GATE. Now finally we are having maximum power transfer. This is the circuit and this is the graph regarding power and RL. Now there is a particular resistance at which the circuit draws maximum power, and this value of RTH is what we are going to calculate, and this is the maximum power it can reach. Now we have certain formulas to keep in mind. First, we are using the basic formula, power equals to I square R, and we are replacing I square R by V by R method. Okay, we are having V as this voltage and the total resistance. Okay, and to RL, this we have replaced. Now VTH and RTH are fixed and RL may vary. Okay, this thing can here vary. Now if in case RL equals to RTH, then this is the formula. Okay, now RTH equals of load equals to RTH of network, then the load will receive maximum power. This is the condition. If RTH of load is equals to RTH of the network, then load will receive maximum power. And if you are short circuiting the terminal and yet maximum current is drawn, then this will yield to 0 power delivered. Okay, and RL is fixed and RTH varies, then we have this formula. So this is all for circuit theorems.